When your exponent inside of a radical is even, like 6 and 10, all you need to do is divide them by 2 to figure out how many go out front. So 6 divided by 2 is 3, so we have x cubed. And 10 divided by 2 is 5, so we have y to the 5th. That's what's left outside, that's your answer. Same thing happens here. Be careful. Some problems may say 15. This should be an 18 right here. You can type this in your calculator or you can factor it out, but the square root of 100 is 10. If you have 10 m's, the square root of that would be 5 m's, or 10 divided by 2 is 5, and 18 divided by 2 is 9. In order to add radicals, you have to have the same number under the radical symbol. Here we don't, but we can simplify this one. 54 can be simplified into 9 and 6, and 9 can be 3 and 3. I have a double, so I'm going to pull it out front. So I'm going to leave my 5 square roots of 6 plus 3 times 9 is 27, and I have square roots of 6. Now I have the same square root, so I can just add my numbers. So 5 plus 27 is 32 square roots of 6. Same thing with subtracting. I have to have the numbers under the radical the same if I can do anything else to it. So I need to simplify these and see if I can get them to be the same. 32 simplifies into 4 and 8, 4 and 2. 4 times 6 is 24 square roots of 2. I can simplify 162 into 9 and 18, 9 and 2. 9 times 6 is 54, so now I have minus 54 square roots of 2. 24 minus 54 is negative 30, and I just leave my square roots the same. So my answer is negative 30 square roots of 2. When you multiply, you're going to multiply the numbers out front. So 5 times 12 is 60. And then you're going to multiply the numbers on the inside also. So 11 times 110 is 1,210. I need to see if I can simplify this. It's not a perfect square, but I do know I can simplify it into 10 and 121. And I know 121 is a perfect square of 11. So I'm going to circle that and pull it out front. 11 times 60 is 660, and left in my square root is the 10. The same concept goes here. You're going to multiply everything on the inside. So 8 times 2 is 16. Then when you multiply variables, you add their exponents. So here we have an invisible 1. So x and x squared would give me x cubed. Y to the 4th and y to the 4th would give me y to the 8th. And now I need to simplify. The square root of 16 I know is 4. If I have 3 x's, I can take out one pair of x. And if I have 8 y's, goes back to numbers 42 and 43, I'm going to divide this by 2, so I have 4 y's that come out front. But I can't forget this x that I couldn't pair up with anything. That still stays inside the radical. Multiplying, here you're just going to distribute. So multiply your inside. So 7 times 3 is 21, so you have the square root of 21. And then you have the square root of 7 times the square root of 5, which is the square root of 35. These aren't the same, so we can't subtract them. Now if I tried to simplify, this would be 3 and 7, this would be 7 and 5, but I don't have any pairs or any doubles, so I can't simplify. So this is my final answer. Dividing is very similar. You need to simplify first if you can. Neither of these are perfect squares, so we can't simplify them as far as anything canceling. If you only have one term on the bottom, you're going to multiply top and bottom by that radical. So a radical of the same thing times itself is like saying the square root of 6 squared, and a square root and a square cancel each other out, so it's just 6. On top, you're going to multiply, so 54 times 6 gives you the square root of 324. And if you take the square root of that, your answer is 18. So you have 18 over 6, which simplifies down to 3. Again, we have one term on the bottom, so we're going to multiply the top and the bottom by that radical. A radical times itself just gives you the number on the inside. Here we're multiplying the numbers out front, which would be 5 and 1, so you leave it as a 5. And then 11 times 3 is 33. That wouldn't simplify or cancel anything out, so that is your correct answer. Here we have two terms on the bottom, so you can't just multiply by the 5 because you're forgetting this part. In order to solve this, you need to multiply by the conjugate. The conjugate is the same as this, but instead of adding, you're subtracting. So you're going to multiply the bottom by the square root of 5 minus 4, and the top by the square root of 5 minus 4. Now on the bottom, you can type that entire thing into your calculator, and it'll give you the answer. It would end up being 5 times, square root of 5 times square root of 5, which is 5, and 4 times 4 is 16, so it would give you negative 11 on the bottom. On top, you're going to distribute. So the square root of 3 times the square root of 5 is the square root of 15, and negative 4 times the square root of 3 is negative 4 square roots of 3. Nothing you can simplify, that's your answer.